Dear all, it's my pleasure to present our recent work about a novel lead compound for advanced prostate cancer. Metastatic castration-resistant prostate cancer directly contributes to the mortality and morbidity of prostate cancer. It is driven by a combination of alterations in a variety of signaling pathways. Considering the limited efficacy of single-target therapy, it is imperative to develop a new class of agents that can simultaneously suppress multiple oncogenic signals involved in metastatic castration-resistant prostate cancer progression. The multi-protein E3 ubiquitin ligase complex, known as SCF, catalyzes substrate ubiquitination for proteasomal degradation. It contains a variable F-box protein and 3 core subunits, SKP1, Colin-1, and RBX1. F-box protein, such as SKP2, beta-TRCP, determines substrate specificity. Elevated SKP2 and loss of its substrate P27, P21 contribute to prostate cancer progression. Highly expressed beta-TRCP substrates, EZH2 and beta-catenin, drive metastatic castration-resistant prostate cancer progression. Upregulation of beta-catenin's targets, c-MYC, cyclin D1, RUNX2, and survivin, is associated with poor prognosis in prostate cancer. Taken together, these results support developing specific agents targeting these SCF-associated oncogenic factors. SKP1 plays a central role in the formation and the function of SCF complex. Interruption of protein-protein interaction between SKP1 and F-box proteins affects the expression and activity of multiple SCF signaling components. In this study, we have developed a novel small molecular SKP1 inhibitor, namely JH501, and evaluated its anti-cancer activities in preclinical models of metastatic castration-resistant prostate cancer. Molecular docking studies suggested that JH501 is a putative inhibitor of SKP1 and F-box proteins interaction. The in vitro and in vivo binding of JH501 and SKP1 was confirmed using biolayer interferometry assay and thermoshift assay, respectively. Immunoprecipitation assay showed that JH501 significantly reduced SKP1-SKP2 interaction. These results indicated that JH501 is a novel SKP1 inhibitor that can disrupt the SKP1 F-box protein interaction. JH501 exhibited potent in vitro cytotoxicity and induced cell cycle arrest and apoptosis in metastatic castration-resistant prostate cancer cells. Molecular studies demonstrated that JH501 affected multiple SCF components critical to metastatic castration-resistant prostate cancer progression. As a lead compound, JH501 has an excellent safety profile. The in vivo efficacy of JH501 was evaluated in 4 independent xenograft models of metastatic castration-resistant prostate cancer, including cell-derived C4-2, C4-2b, and CW2-RV1 xenografts, and patient-derived LuCap 23.1 xenografts. All these results demonstrated that JH501 is a safe and efficacious monotherapy in suppressing the growth of metastatic castration-resistant prostate cancer. In conclusion, pharmacological inhibition of SKP1 F-box protein interaction by JH501 is a novel strategy for the treatment of metastatic castration-resistant prostate cancer. Considering the higher mortality and morbidity of prostate cancer in African Americans compared with other racial populations, we are evaluating the capacity of JH501 against advanced prostate cancer in representative models of African American prostate cancer. Thank you so much for your attention.